And Radhe Radhe. So it's our sixth live. Alright, it's our sixth live. Um, Today we'll be discussing about the Golangs, like the concurrency in Golang. That is about the while discussing about the bugs. We'll try to discover new features within the Golang. We'll try to get to know more about Golang, well more deeper knowledge about the Golang and the concurrency handling as well. We'll try to get over the whole concept through the the docs, official docs of Golang itself. A lot of different libraries that have been hosted of on the official website of Golang, as well as also we'll try to cover or get the whole knowledge through through the a lot of different bugs and different blogs and case studies and a lot of other things as well, or any particular kind of the CVEs as well that might have been focusing or highlighting any particular feature of Golang. So we'll try to cover them all. Yeah. So right, let me just kind of share my screen. Let me open my Google Docs at first, so that we can just kind of list which all particular things we'll try to cover in this live session of ours. Right. Okay, so let me share my, let me kind of see my own live as well, so that in any particular case my network kind of get broken in the middle of the whole live. At that moment I can just kind of watch if everything's been going as if the live is still up and running. It's and that's the whole point. Let me just kind of start it. Perfect. If anyone is present right now in the live, they can just kind of comment as well, so that they can just kind of hand over any particular question that they might be having. They can just kind of ping or flag any general question or issue that they might be having at that moment. They can just kind of right over there. Let me just ping onto the whole live chat myself as well. Everyone. All right, perfect. So I'll be seeing any live chat that any particular person, if he does have any particular kind of question in your mind, then you can just kind of ping or just write up any doubt or any general kind of issue that you might be having in your mind as well, in order to ask that if what are the major goals that we'll be covering, or why are we organizing this particular kind of live session at the moment. So that's the whole point of this live, that we'll try to cover the concurrency part of Golang, and then later at the time of New Year, at that moment I've just kind of decided that we'll also try to cover Rust as well. Rust as well as Golang, both of these particular languages that you might have heard are really interesting, as well as also they are really helpful when you are discussing about the special purpose kind of the languages, mainly upon the cloud. You might have heard about them, both of them. Golang is majorly uh, a lot beneficial when it comes to the API handling, as well as also the whole it kind of works as the brain of the whole architecture, while on the other hand the Rust actually helps plays around as a kind of giving the whole body to the whole architecture. Like you might be really intelligent kind of a person. It's kind of great thing, but then too, in order to stay alive, you still need to make up your physique as well. In the same way, if you really want to keep your systems up and running at that moment, it's really good to orchestrate each and every particular service that might be been orchestrated well in the whole architecture, that might be made possible with the help of the Golang, but also still you'll need Rust as well to make up that whole physical, not the physical, but the main environment of the architecture of your cloud infrastructure as well, in order to secure your whole cloud architecture. So that's the whole point. We'll try to cover the Rust on the 1st January. But right now, we'll try to cover the concurrency part of the Golang, and it's one of the most important kind of part. We'll try to cover. If anyone's new over here, we can also start it from the basics. You can just kind of ask me in the comments. Otherwise, we will just skip to the whole concurrency part. Otherwise, I'll also try to pitch some of the smaller components as well that are available and that are present in Golang and are kind of different when compared to the C, C++, Java, and a lot of the programming languages as well that are available at the moment. So I'll try to take all of them. Let me just kind of connect it. Perfect. All right. So, hey everyone, Radhe Radhe. I guess more people have joined right now. Right, so here's the whole list of the number of the live sessions that we have held till now. The first one was we were discussing about the K gateway at that moment, about the latest releases and a lot of different features that were included at that time. We were discussing about the global policies as well and a lot of other things as well. We'll also try to take K gateways, Golang codes as well at some day. It's you might consider calling it as Golang or either Go. It's a programming language that was designed or being developed by Google at that time. Right. So in the live 2, we discussed about the Helm and Argo rollouts, and the live 3 was all about the platform engineering core fundamentals, and we were discussing about some of the topics and the whole major different domains that were being involved in the whole platform engineering associate exam, CNPE, as well as also CNPA at the CNCF certificates. You might have, I have, flagged the those particular links as well to if anyone really wants to buy those particular courses as well, then you might head on to those links and just kind of buy them. In the live 4, we discussed about the CVEs as well as also the common vulnerability exploits. There are a lot of different security threats that you might have seen in the whole architecture or different services as well as softwares. So it's really important that we get to know about them all, and that's what we actually discussed in the live 4. Then in the live 5, we continued our platform engineering fundamentals, and in the live 6, we discussed about the Redis. Now in the live 7, we'll try to cover the Go concurrency. We'll try to get most of our knowledge from the official documents, the documentation of Golang. Otherwise, we'll also try to take reference from some of the books as well. I'll consider Concurrency with Go that has been published by OLE and has been written by. I actually have that particular book right now. It's been written by Catherine Cox. So a huge shout out to her as well. Right. So let me just ping my docs as well. All right. Here it is. Go's programming language. All right. Official link. Documentation. Here it is. If any particular person really want to know a lot more about this particular language, then they can just kind of head on to them. If anyone's watching at the moment and they really want to get access to this particular Google Doc as well, then I have I have dropped its link as well in the description. If I haven't, then let me just kind of mention it. I think I haven't. Right. Yeah. Now I have live docs. Right. Now you can just kind of see. It will be up till now. Yes, it is. Right. So let's head on to our documentation of Go. Hey, vision goal. Right. Thanks for coming. Are they? Yes, yeah. Right, so here is our documentation of Go. Let me know if my voice is kind of clear and it's pretty audible at the moment. If it is, then yeah, it will be good. It will be great because I have changed my whole background. My location I've relocated kind of right now, so I'll try to perfect. So as you can see, it's the we'll try to keep it a lot basic right now for the moment because I don't want to just move a rush towards the whole point of the concurrency part because it is a really complex kind of a topic at the moment in Golang, and it's the major reason why Golang is actually being why Go is being preferred by a lot of different engineers as well as also by why they have been making a lot of money out of it. And more importantly, why it's more favorable for building up your cloud environments as well. So I don't want to rush in any particular thing, and I'll try to keep it a lot basic at the moment for now, and then later we can maybe get over to discuss about the go routines as well as the channels and a lot of other things as well. I might drop a lot of different facts as well because you can't really talk about any particular programming language and can't kind of ask any tech guy to follow any programming language until or unless you're going to find something pretty kind of rare when compared to the language in which he's been coding at the moment. So if any C guy or any C++ guy at the moment or any NPM guy might come across and I might pitch this language in front of him, then I might have to keep a lot of different facts as well in front of him in order to kind of involve him as well, involve and get his hands as well dirty in this whole process. Right, so here's the whole documentation. Installing Go, you can just kind of install it and start it. So yeah, they are also right. So in Go, there's whenever you there's a particular command that you usually pass on as a Go mod tidy. So that makes up kind of a dot mod file. It's a whole file of the modules that has been imported from the different exported libraries that has been used in your code base. So that and they won't um, so that they won't kind of increase the whole complexity of your document of any particular code base in your file. So that's why they've been kept as an isolated part within your same directory or either in the same whole project. That's what I'm saying at the moment. So they'll kind of keep all these modules registry. They'll kind of be and the dot mod file is a kind of a registry of the different dependencies or to which your whole code base actually depends upon. So they'll be containing the names as well as the links and the whole the mod files or different imported libraries as well as also dependencies that is being used is being your code base has been using at the moment. So it will be containing a whole list of all of those particular different modules. So yeah, this is that. Also from the security point of view, it is really important. Like from there might be a lot of different criterias. Yeah, that's another fact. All right, so in a lot of different programming languages, you might have to consider giving reference to the different imported modules as well as a lot of different libraries that you might have been using at the moment. But also, uh, you don't really want to you still want to keep it behind an abstraction layer. Right, you don't really want to reveal each and every particular thing that you've been using in your application if it isn't even if it is an open source language, then too you will have to keep certain things in mind that so that there might the things won't go wrong and will stay up and running reward action. So that's the whole point of it. The whole list or the directory or the registry of all the modules as well as the libraries have been kept isolated, so that you won't you won't mistakenly push it on the public registry. So that's the whole point of it. Go mod init, and then afterwards, here's the big thing: import fmt. We'll be using it for the general instruction as well as the general functions and the modes as well, like for the printing part of hello world. So here's the whole thing. We haven't used it because it's kind of being included as a default feature. Otherwise, if you would include something else, yeah, here you can see it's go more tidy. So yeah, it's the whole part of it. Go more tidy, then you can do just go run. If you are having a lot of different microservices, also let me just frame it in a way so that you can get to know about why do we need Golang in the first instance. So Golang is really kind of important for any particular person who's been trying to build up a microservice kind of an architecture. They'll be having all right. So there are two different kind of architecture of any particular application. One of them is the monolithic application, in which everything will be working on the same service. There will be certain different kind of the components, but also they will be working on the same hood. So they won't go as separated from each other. They won't be isolated as much. So they all will be working together, will be well orchestrated, but still they will be working on the same hood and under the same application while working. Acting as the same service. On the other hand, the microservice architecture is a well-distributed kind of architecture where there are a lot of different services that are, serving your different components of the whole application. As if, let's say, I have different parts of the different components of my application that are serving or been acting as a front end. Another one is the back end. Some of them could be like a database of the whole, different kind of the data that I'm handling at the moment of different users right now. Another one could be for the security, and the other one could be of the payment gateway as well. If I'm kind of handling a certain kind of a platform in which I've been providing some kind of subscription module as well to any particular person. So in that case, in that scenario, we'll be having different kind of the components being deployed as in the form of the services, and those different services would be considered as the microservices. All of them would be connected along with each other and will be acting as a microservice architecture, in which everything would be orchestrated with the help of different the codes as well as different a control plane kind of a way as well. The Kubernetes usually helps you a lot in that scenario for better orchestration between different components of the whole your cloud environment. So if in this particular kind of alright, so for the go run part, you can see right, there's a simple single file, a monolithic application. Then in that particular scenario, you can just write go run and whatever the name is of your file .go, because the extension part is obviously go. If you're writing in Golang, in the Go programming language at the moment. So that's the whole part of running a simple single application. But while on the other hand, if you have a lot of different microservices or the different applications that has been deployed on your environment, and then you want to run all of them all together in a well orchestrated manner, then in that case you can just run kind of go run dot. What will this dot mean? That each and every particular file that is present at the moment of Go programming language within the same directory, they all will run all at once. So yeah, that's the whole the most general kind of a thing. For the tutorials, you can just head on to the tutorial section, I guess. Fine. Getting started, create a module, multi-part tutorial that introduces common programming language features for the Go perspective. And starting with multi-module workspace, yeah, that's all I was saying. Relational database, developing a RESTful API with Go engine. Yeah, Go and Gin library is very important. I will try to make a whole project out of it as well in the latest section, I guess. For the moment, let's for the generics, fuzzing, and Google check, all of them are really a part of the whole process. So we have our nothing's new as such. As far as can go and starting with Go. Yeah, create a module. Starting with multi-module workspace. Yeah, it's kind of perfect. Right. Yeah. So let's create a hello.go in the whole hello directory with following contents: fmt golang.org, go run, go work in it, and it will kind of initialize the whole directory for using the Go environment. So any particular application that has been including Go as your programming language, it will be showing the whole present version of the Go programming language that we are using. Run code. Right. So I guess these all kind of things are very um, kind of very basic. I'll go somewhere else, I guess. Yeah, developing a RESTful API with Go engine. Or it might be a bit more, or yeah, just let's get going with this. Google Cloud Shell. The RESTful APIs might have been, already introduced with the CRUD applications for, performing any CRUD operations. That is for the creation, rename, update as well as delete part of your whole application or any particular file or the API that has been sent either to the client side or either to the server side. You can just use them, and here we are defining them all. It's Golang is really kind of helpful if you are building some kind of an API as well for your whole application. So in that case, it's been trying to set the whole environment for you in order you really want to use them all. Create the data. It is album struct. We're using struct with the different kind of the types as well that has been included in the node. Here we have the ID string. Since we are referencing the APIs and the use of RESTful APIs right at the moment, that's why a lot of different libraries as well as a lot of different things you should use JSON, because they'll kind of act as a kind of an I would say an interface between your Go code and to the user or to the any particular directory that you've been referencing at the moment, and that whole directory or the library will be whole structured in the form of the JSON. That's why that's what it's been using. We have ID as one of its component. Its type is string, obviously, and the JSON's ID we've set as the ID, because we will be kind of structuring the whole part in the various different formats. And we have the arrow struct, JSON, ID, title, artist, price. Also, for if anyone's not kind of introduced along with the interfaces within Golang, there are a lot of different programming languages as well that are being using interfaces. So interfaces are they are the same things, like not I would say kind of same things that the JSON like struct part, but still in the interfaces you doesn't have to kind of really reference about the types as well of each and every particular entry that you've been entering in your whole database at the moment. You can just, if you want to reference a particular function that you've been using within your application or in your whole Go file, then you can just put it over there as the whole function part, and then They will just go over there and just find out which type they've been referencing to at the moment. So, and the whole came up with the return as well, and the output say in the same manner in which the your whole main file has been coded till now. Right, so we have our albums. Um, we have the handler function as well to return all the particular items that we've been asked to do. So this you'll write the logic to prepare a response, code to map the request to your logic, right? That is main. We use the net and HTTP as our libraries and the modules, Gen and Gonic. That's awesome. We save them and just yeah. Oh, all right. So go get dot will return you the whole list of the modules as well as the dependencies on which your whole code base is relies on when defined that way, that format. So here we design our whole code base in a way as well as different structs and the var albums. Right. So also for the variables part within the whole structure, you can variable is like there are different constants that will stay as they are for the whole structure of your code base, while the var part will actually keeps it will keep up as a kind of a variable values for your uh, keywords or any particular uh, methods that you've been including at the moment. So they'll keep as the var. Either you can just put a var keyword in front of the whole line, or either you can just kind of put an album and then just uh, put a semicolon as well. And then they can also act the same way. Alright, so right over here we have structured the struct part as well as also the albums. That has been set as the var, and then we have been referencing JSON's ID. We can see ID has been kept as being set up as the one, first, second, and then third. The titles has been also established over here. We'll be considering about the artist name as well and the price as well. So I think we've been building up some kind of CD or some music album distribution service right now. So design the whole core of it, and then later, here's the whole function that we've been referring to right now. Standard JSON, right? JSON file that we set up at the first core. Then our main function, it will call set up the router. That was I was saying. If it is a var function, var means variable, you can either put a var and then router, like you can just put a var then router then gin.default, or either you can just put this particular kind of a symbol in which you will be referencing the router as a kind of a variable function, or I mean variable keyword. It's a variable. A router is a variable. So and then later we've been calling forwarding a get API, a get request for the rest. The whole server router.get get albums, and then the run part. I think the run is a part of the RPC, I guess, right? The REST is responsible for handling the kind of the response and request or the part from the clients and from the server side. But if you really want to perform any particular kind of an operation onto the another server that is being present right now, like you'll be having a whole directory of different databases as well as a lot of different operations that might have been going on in the local server at that any particular place where I've been wherever it have been kind of deployed at the moment. And then later if you run them, like kind of perform any particular kind of an operation in that particular framework, you will be using RPC. You might have a lot of different REST APIs as well. It's not a kind of strict rule that it will be in RPC. Like I've seen a lot, like the gRPC, the Google's RPC, remote procedure call. RPC stands for remote procedure call. That's why it is responsible for performing any particular kind of an operation. So Go usually gets along a lot in a better way along with the gRPC in compared to the other RPC frameworks that are available at the moment. So yeah, it will be forwarding this kind of request as well. Initialize a Go router using default feature using the get function to associate get HTTP methods and album, and then it will run the function to attach the router. Perfect. Engine gone engine. Save the main.go, and then later you can just view whichever libraries you've been using in your code right now. Go run, and then the curl. You can kind of just over here, as you can see, it's been running over the localhost 8080. So that's why it's been sending this particular. You can see whichever function has been performed or will be performing over your localhost 8080. So that's why I can say. Otherwise, you could have just use or just insert it over your domain, the whole domain as well of your website, whichever you've been using at the moment, and then any part, a local part of your domain as well, like within the application. For example, any movie has to be pushed on the main repository or the main website of Amazon Prime, and then Amazon.in of then the Amazon.com service. Right, those are different parts of your whole APIs. Yeah, I mean domain names. I don't know if I'm if that is all stable right now. Perfect. So add code to add albums, data from the list of albums, permission post albums, the album. Alright, so I think we have a message. Oh. Also, there's a lot of different community posts as well as groups as well that are available over the over Slack, as well as also on the Discord, and also on the Google groups as well. So Google groups usually includes a lot of different a huge community of different developers that have been responsible for taking care of if the whole thing have been going well running and it doesn't breaks out due to any particular kind of a vulnerability, exploit, or any attacks that might have been seen by the developers right now. Like any particular kind of update or any announcement that has to be made by the community, then you can find it over there on the the official Google groups of Golang, of Go programming language, or either you can just add on to the Slack as well. Slack does hold a huge community of Gophers. But the people who usually being a part of the whole Go community, they usually consider themselves as the Gophers. So yeah, it's a huge community. You can even find a lot of different CVEs and security threats as well, related security threats, and you can just migrate the whole environments of the whole core environment of your application in case of any particular kind of a problem. Right. So here we have mail. Guess yeah. Soon will run it on our local host, include and header has been also set. That's what I was saying. On the whole domain name you will have a lot of different headers as well. So header has been set to the content type, that's the application JSON request post command or the post function has been passed. So yeah, post method has been passed for the APIs frameworks. So we can see it's a 201 status, that is a successful status created. Perfect. I have made a kind of a microservice applications as well. I have been using Go on a massive scale. like it will be handling your RPC frameworks as well through the gRPC. It will be using Elasticsearch as well, and the PostgreSQL as well, a lot of different things. So it's a very interesting kind of project. Maybe I'll try to cover it after we are done with the concurrency part as well. Writing a handler to return a specific item, the album by ID. It's it's a variable of ID. C parameter that has been passed is ID. SC is alright. We've been considering gen.context when we consider G. C. Its parameter has been set to ID. Let me see if we have set them up earlier as well. We have any particular kind of a struct as well for them. Yeah, ID C dot. Which one was it? C dot one. So the parameter is just of the parameters, and then it is considering the part of the IDs that we have also already mentioned in our struct file. See, ID and the JSON part has also been set so that the whole thing or the whole architecture works in a well orchestrated manner without breaking. So for a range has been set to albums. For the iteration part of our for loop, if it doesn't have as many we didn't have as many conditions that has to be set for our for loop. For right now, we can just kind of pass on this dash, or kind of leave behind the further details to this manner. Set to /a, it will within the whole range of albums that has been passed by us. I think we have defined the whole album as well in another part. I guess it was a function or either a method, kind of a method. So yeah, it's the album. If a.id is equals to id, then it will c.entire JSON has to be stated as OK, has to be written. Right, return. And you see entire JSON state is not found. If the a.id has been set, if it hasn't been found as id, then it will return this response from the server side to the client side upon forwarding a request. It's been, we have function main router using default get post and run. It's the whole completion and the completed code as well. And kind of I don't really want to, right. So quick update. I'll be just back in 3-4 minutes. Till then, you don't go anywhere. Just view over, get over the whole kind of the whole code as well. Let me just mention it in the Google Docs as well. Right. So we have if any particular person really want to go over the whole code as well of the the example that we took right now, then they can just go over the docs as well, Google Docs that I have updated in the whole description, in the description. So example, Gymgonic official go website example. This is the link to that. I've passed it. Right. Let me just come. दिया जलाते हैं राधे राधे अभी आया muted Right. Right. Oh, there are still six people. Thanks a lot for staying for this long. Right. So let's again uh, iterate over the whole each and every particular line that has been mentioned in this whole particular code, and then later we'll try to cover some other concepts as well, or other particular kind of the sections as well that has been mentioned in the whole file. For now, it's all right. So it's importing these two libraries. One of them is net, and the other one is HTTP. And then the github.com Gingonic official repository that's been referenced in the whole import libraries. As soon you'll do go mod tidy, at that moment you'll form a separate kind of a mod file that will be containing the whole list of the modules as well as all the particular different kind of the libraries and the dependency that's been handled by our code uh, in order to handle the whole security perspective of your application as well, in the case of the microservices as well as the micro the monolithic application as well. It's a monolithic application. It isn't has as many different files at the moment that has been orchestrated or been well connected right now. Otherwise, Golang is being highly preferred due to its well orchestration and highly it's well connectivity and high it has a lot lesser uh, I would say dependencies on different. You can build different kind of the microservices containing or handling different components and set up different kind of rules and security perspectives and different flows as well, data ingestion and data flows as well, and the traffic flows for each for performing any particular kind of an operation as well for your site or for your architecture for your application, microservice application. So here we have the whole struct of albums that will be referencing these four, you know, um, these four different kind of the, I would say, values. One of them is ID, and these four different datas. One of them is ID that's been set as a type being string, and the title, artist, and price. Price will be containing the the float 64. Uh, then we have the album. Album is a var, that is the variable of album that has been set as a global variable for the whole of our file var album. It's kind of slice of no it's yeah it's kind of not a slice but an array or different multidimensional arrays as well. There has been that will be considering these three different data entries as well. Uh, that will be handling, I mean, referencing to the struct at the moment. I think we'll be announcing struct at some other place that will be taking care of the albums as well. Then the main router.get, different APIs function that has been passed. The get post runs as well. Right. Just wait. Right. So I think we should kind of hold our live in some other room, or either we can just handle it over here. No, it's good. It's fine. Main. All right. So it will be referencing to gen.default. It will be calling the gen. Yeah, right over here. It will be calling the import libraries that we mentioned earlier. That's gen. router dot router, it will be considering these gen by default, and then get will be get function has been defined to take the albums and get albums. It will be defining this get albums function as a different one. Yeah, over here, get album c with gen dot context, c dot indented json. Status has been set to status okay, http dot status okay for the albums for us. And it's yeah, so it's get albums, right? Post albums, it's just a get function for the get albums. While on the other hand, if you doesn't know as much about the whole album name or anything else, then you can just reference the ID as well of the album that has been deployed. That will be referencing the get albums by IDs over here. We'll try to kind of just iterate over the whole for loop. We'll kind of take the for loops. Yeah, over here as you can see. Think the loops, there's for loops, it will be considering the different IDs because it's been set as the get albums by ID. So you'll be considering different IDs iterate over the whole database of the different albums that have been set with different IDs. So we'll kind of iterate over them all. Then later indented, sorry, post albums. There we have another yeah, over here post albums, new albums, it's been said as wow. So we'll be defining it as well. Albums, any particular album that we might have, we might really want to post any particular latest release that might have been kind of uploaded. We'll kind of post it, kind of append it in the whole arrays or the multidimensional arrays or different different data entry that has been stored in our environment or in our local environment at that moment. So we'll kind of try to get over with adding albums as albums, append over that particular multi-dimensional array albums, and then the new album, that's what we've been referencing to right now. Album has been I guess it's been, yeah, it will be taking care of the albums, and then we'll be adding a new album. Yeah, that was my brother. So get albums. All right. I think we should kind of relocate to some other room for now and just mute myself for now. Right, so here I am. Thanks for staying. Right, so does anyone have any particular kind of doubt, or if you really want to introduce yourself as well to the whole stream, then it will be kind of great thing. There are 9 people right now, so it will be an amazing thing if you could kind of just maybe write something, drop something out in the whole live message or the chat as well. Let me know where you guys are from. Maybe you just have any other kind of request as well. I just have a lot of free time for now today, because it will be New Year in some days, so that's why maybe I can kind of just review some rants as well, go over some other parts as well of the Golang official website, or then I can just kind of show or iterate over the whole project that I also made previously personally. Right, so here we have the whole Golang. We have different packages as well. You can just kind of review them all in package or symbol. We use a lot of different packages as well, so there we can see, ask for. We just use Gin and Gonic, then we can review them as well. Gin Web Framework. Here we are. Like the Go for or the Golang, Go does have a lot of really kind of interesting different kind of symbols as well, and a lot of different plushies as well. If you ever kind of attend any Go for Con as well in the future, then they does have a lot of an amazing community, by the way. A lot of different backend engineers, and really you'll find a lot of different people that does know a lot about the whole industry and the domain in which they've been working right now. So that's kind of great. And right, so here we have Gin is a web framework written in Golang, in Go. Sorry for calling it calling it out again and again. Golang. I know, like the Golang was the project's name, was the initial name of it, but it's been referenced as Go for now. So yeah, that's the major thing. As its feature as a Martini-like API with performance that is up to 40 times faster than the HTTP router. If you need performance and good productivity, you'll love Gin. I've built a lot of different projects in Gin as well. Maybe I can just kind of share them all with you as well in the future. Maybe in the next live stream as well. Let's kind of just go through the whole features or different packages, as well as a lot of different frameworks or the features that are available in Go. We does have particular different example as well of Gin right now. Gin's key features are zero allocation router, speed, middleware support, crash-free JSON validation as well. Yeah, that's why it was again and again referencing towards the JSON as well, because it performs the JSON validation as well. So that's why it will be used in all as well. So and also it will be working as a kind of an interface between your Go file and the JSON support as well. So a JSON file that you've been using for now. So you'll need, in some cases you'll need to use JSON as well in order to structure it in a lot better format. Go build, run, test. Alternatively, you can just go get. Yeah, either you can import it, or either you can just go get, do the whole go get command as well. We have the main function. R has been set to gin.default. R.get. The R variable has been set to be using gin for the default feature, so that's why R has been passed, like the get method has been passed along with the R, that is for the gin package. Ping, that is function c.gin.context, c.json http status okay, gin, and then the message has been set to pong. All right. So if you will pass this particular kind of method, then the whole thing, when the whole while using Gin, then you'll get a message. Then you'll get a message will drop to you as pong r.run listen and serve on 8080 local host port, as mostly kind of a default thing that has been included in most of the different code examples. Even in my documentation as well, I've written a bunch of different documentations as well. I've been also using the same test, like same code for the testing environments. Yeah, so here we are. We have different kind of amazing projects that are using Gin web framework. That's GoRush, a push notification server, and that's awesome. FM project, a container native cloud agnostic server platform, serverless platform, and that's kind of awesome. Let's review it. All right, so here it is. Yeah, let me pass. Yeah, this we used gin in the last example that we took, so that's why I've kind of shared the whole examples link in the doc. So that's why it's my duty that I should also pass on the whole information about the gin package that we have used. A lot of information has been encapsulated in that kind of thing. And it's not as much abstracted. You can know a lot more things in that particular documentation about gym package. Right. There it is. Perfect. So we got to know about another amazing project within the whole gym documentation, that was the FN project. You can also contribute to this amazing community of FN project, either to the gin as well. I guess if they will be using gin go, uh, do they have it on their official website? Yep, I guess. Yeah, gin got it. Oh no, no. I don't know. Yeah, all right, perfect. Here we have the whole official repo of gin. Here we have gin. It is a high-performance HTTP web framework written in Go. It provides a Martini-like API with significantly better performance, up to 40 times faster. It was all been written, was kind of written for the Go's original documentation as well. Oh, that's kind of awesome. Yeah, so here it is, Gin 1.11.10. It's the latest update that has been pushed by the community, I guess. You can let know about why do you really want to choose Gin, what are some of its core features, or any particular updates that might have been pushed by the community. You can just go over there as well. Oh, it's not been shared. Sorry. So here we are on the official web of Gin web framework. That is all the same that was being mentioned over the official website or the documentation or the goals documentation as well. So yeah, we have the key features, combine specialities, simplicities of Express.js style routing with goals, performance characteristics. Is kind of an alternative, is kind of an HTTP web framework. You can use it along with the Express.js or either with the Go as well. Right. We have Gen 1.11.0, 1.11, or so will be have, it might be flagging different updates that might have been pushed to it. Yeah, it's the benchmarks, name, performance bottlenecks, official documentation. Yeah, it's on Go. Yeah, it's the same one that I was referencing. Right. So if you really want to contribute, you can either report bugs such as features, improve documentation, submit code, or write tests as well. It's part of the whole open source community member. it does hold a lot of different issues. Last week, 3 weeks, 29 days ago, I pull requests as well. I don't know if it does have any particular project that's been going on right now. No, it does not. The whole has the whole community, the community members, 1.3K followers. I've been also following it right now. Perfect. Oh, camera wasn't. All right. So let's head back to Go. Oh, we. That's an amazing interface. GoGen. Awesome. So also, what were some of the symbols of Gen? Let's see. Gen struct. All right. Yeah, here it is. Stretching. Right, so let's head back to our official website of Go. We were considering the multi-module workspaces. We discussed this particular example. We even discussed about the API, RESTful APIs with Go engine as well. Later we can also play around with the generics or the fuzzing part. Right now, the whole the motive of this particular live was the concurrency part. So let's get to know about something else about the concurrency as well. Like either about the Go routines or either about the channels or a lot of other things as well. So that's why let's kind of cover those particular topics as well. Yeah, let's just give me a minute. Right. So let's search it over here. Docs goes back. Might be having it, I guess. Go routines, like Go routines, it does have. Right, so on the OS level, like on the lowest level of abstraction, at that particular layer, you have, for performing any particular kind of a concurrent logic at the lowest level of the abstraction at that time, you does hold or kind of produce a lot of different OS threads, the operating system threads, and you allocate a lot of different memory, or you give access or allocate memory to the spaces between them, those different the OS threads. But if he doesn't have as many OS, like you have a lot of different OS threads that have been asked for in reference to the memory, like for performing any particular kind of a concurrent operation, that you might require a lot more memory as compared to the whole operating system or the whole memory that is present along with the whole system. At that moment, instead of producing different OS threads, you might consider making a pool of the threads or the OS threads at that time. But these OS threads will kind of introduce a lot of complexities as well. So that's why, while managing along or going along with the Go programming language, at that moment we kind of replace the whole concept of, not the whole concept, but we kind of replace the OS threads along with the Go routines. So Go routine is kind of responsible for handling the different memory access, as well as also performing any particular kind of the concurrent operations. It's the minimum layer, with the that's been it's a really powerful concept for performing any particular kind of functions within Go. It can provide you with the logs functionality, with the sync and channels, and a lot of other things as well. So that's why the OS threads was replaced with the Go routines part, and the mutex was being replaced with the channels in Go. So let's kind of Hey, Ari. Nice to see you. Right, let's kind of read over the official documentation. Let's get to know a bit more the official documentation. Kind of, I just kind of explain about a lot of different concepts while giving the examples, as well as also might also write a lot of different codes as well to produce different outputs. But also, official documentation would be a lot better option to refer, because it will be kind of having a lot precise definition, accurate definition as compared to mine. Mine. Do you guys know about iota? Like, if you does what is like, yeah, let's kind of see. Like, the iota has been sent been kept with the where you doesn't really want to hold as but doesn't really want to kind of announce any particular as much of an memory to any particular kind of a variable, any particular kind of a value to any variable. At that time you might use the iota. Then later you can just introduce a lot of different values to the same variables. You can see the const c0, c1, c2 are the iota has been set to iota, and then the another part of the const a has been set to 1, b has been set to 1, c has been set to 3, and then d to 1. Perfect. Const, yeah, so here we have all these different concepts about the iota. Oh, that's awesome. A constant declaration. The predefined identifier iota represents the succession and type integer constants. It's a value in the index of the respective const spec in that constant declaration starting at 0. It can be used to construct a set of related constants. Perfect. As I said. By definition, multiple uses of iota and the same concept all have the same value. Yeah, then we have the type declaration, type definition. We'll cover them all. For now, let's kind of get to know a bit about the, yeah, it might be in concurrency, yes, or in blocks, but in the concurrency part. If there's any other person as well who's present in live, then they can also drop a comment, or in the live chat. It'll kind of feel amazing to know that there are a lot of different people there who are actively watching. Right, so yeah, go routine. Oh, right, go routine. Go statement starts with the execution of a function called as an independent concurrent thread of control of Go routine within the same address space. Yeah, also the Go routines, all the particular threads of the control has been allocated with the same address space, so that you can perform a lot of different operations along with those mainly the locking in or sharing the context sharing as well along with the different parts of your operation. That will be an amazing play of the whole of designing the whole architecture of the application. The expression must be a function or method call. It cannot be parenthesized, obviously. Yeah, so its syntax is like just like go, and then the f x y z. The x y and z would be declared within the same function or the same operation, and then later that the f or the function, that whole function with x y and z parameters would be declared or handled in the another or the next operation. So it's a really fun kind of an concept that will be a lot better while being put you know uh, in the practical manner, instead of just speaking about the theories. We'll also try to look over the whole the official code for different APIs that's been used in the Kubernetes or a lot of different cloud environments as well. cloud-native environments. But it is we'll try to take the Kubernetes as well as also K-Gateway and a lot of different projects as well. You might have heard about the Open Telemetry or Prometheus or eBPF and a lot of other things as well. eBPF, I guess, it isn't being designed in Go specifically, but there are a lot of different tools that are specifically being produced or being uh, written in Go. One of them is Kubernetes for sure. Another one is I guess QoS is also one of them, and then the K gateway. Agent gateway has been written in Rust because the K gateway has been taking control of the control plane, so it's being kept as Go. While on the other hand, the agent gateway has been taking care of the data plane, so that's why it's been written in Rust instead. Yeah, we'll kind of try to take all of them. I guess it's been kind of, yeah, it's already more than an hour. All right, so we have Go routines. Perfect. Perfect. So I think should we still take Go, or else we should take some other examples, I guess. All right, so we have I think it hasn't been mentioned. Here it is. Like as I saw, Golang, like the core routines was the first one was being mentioned in Go examples. Maybe we can just refer to the channels. That's also the part of the handling concurrency. Or maybe we can also just kind of know a little bit more about the whole Golang concurrency part from some of the conferences that might have been taken place earlier. One of them is the GopherCon. Let's try to refer it. GopherCon core routines or the concurrency part. Right, here we are. GopherCon 25. I think this year and GopherCon was held in. It has been held in a lot of different countries. One of them is Singapore. Also in India, it was held in at Jaipur. At Jaipur, we had it in the month of August, I guess, or in September. I don't know. But also, it was being held at UK, at US, and a lot of other countries as well. We can just goes trace tooling and concurrency. understanding channels. It's oh, it is old. 2 weeks ago.
See, it takes a topic, and then it takes a slice of documents. In our case, maybe a bunch of documents that are.
Let me know if it is audible right now. Let me hear myself. Sorry for hearing you guys. Yeah, it's audible. All right. Sorry for that.
Our RSS news feeds. And the idea is that we want to see how many times this particular topic shows in any given news feed. And this version of the algorithm is fairly simple. It's single threaded there, right? We're going to do a linear traversal across all the docs. We're going to open up that file. We're going to read the whole thing into memory. We'll unmarshal that into a Go struct. And then we'll just use string.contains, looking at the title or description. And every time we find that particular topic in there, we'll increment that found by 1, and then we'll return what that is. Now, I don't want to have a lot of documents here, so I've created this one news feed. It's way old. It's back from like 2017. And the idea is we're going to start off with saying that we're going to have 4,000 of these. So let's just pretend there's 4,000 unique documents. Ideally, I want to be able to process millions of documents, but for now, let's just say we're going to deal with 4,000. All right. So I can go ahead and I can build this program. And I can even use my little time program to get a basic sort of wall clock. And if I run this, I'm going to run everything twice because warm the machine up a little bit. So if I run this right now, it looks like that out of those 4,000 files, we found that topic. I think the topic was president. We found it 28,000 times, and it took a little over a second for that to happen. Now, if we were only going to process 4,000 files, I'd say we're done. I mean, that's fast enough, okay? But let's say we've decided that that isn't fast enough. We've got to figure out what is potentially slowing this thing down. Now, we could do a CPU profile, and if I had time and I did that, we would basically see in that profile that what's sort of slowing us down are system calls going on in here. And at the end of the day, unless I can buy a much bigger machine, right, the system calls are what's there. So profiling is really cool. And we did some profiling yesterday, but I think one of the problems with profiling is it can only show you what's happening. And sometimes your problem isn't based on what's happening, it's based on what's not happening. And this is where the trace tool comes in, because the trace tool can also show us, in many cases, what's not happening in the program. Now, I've got a program that runs fairly quickly. So what's pretty cool is that the standard library has this trace package in part of the runtime. Trace package to start a trace, I'll send it to standard out, stop it. But you can get traces running benchmarks, running tests. You have all these options to sort of generate. Now, the trace data is down to like the microsecond, produces a lot of data. So you really want to be very targeted when we're running this. This is a beautiful program. It's running like a second, right? So it's perfect. So let me turn that on. Let me go here and we'll build it again. And this time when we run it, we'll do the time again. And I'm going to send everything to t.out because that's where we're putting it. And again, I'm going to run it twice. And now I have a t.out that's about 1.3 meg. I mean, that thing ran for a second. And I already got a meg of sort of data there. All right, let's get a sense of, let's take a look at the trace. So I can go to go tool, trace, t.out, and we'll bring up the browser. I'll make this a little bigger as we go. And over the years, they've added a lot of cool stuff in here. Maybe somebody one day will give a talk on more than this first link, which is what I'm going to press, which is going to show us that trace data at the proc level. So I have a machine here that's got 16 cores, so I'll have 16 procs. And you can see a little bit here what's going on, but I'm going to expand this just a tiny bit. So I'm going to even see if I can make it a little bit bigger for you, and I can expand some stuff here. All right. So real quick, you can see the top line is showing you how many go routines at any given really microsecond, but when the milliseconds there, we can see our heap graphs, we can see operating system threads, you can see GC, you can see pacing, and then you can see go routines that are executing across the different procs. In fact, I told you I've got 16 procs and really only 7 of them are showing up. What's also cool is if it's important to you, you can sort of click on these go routines. You can see a stack trace of what was happening at that time on that given go routine. There's a lot of stuff there. But remember, this talk is about, is there something in this trace that's going to help us sort of identify why this program isn't running as fast as it otherwise could be? And if you just look at this view alone, I think it ends up being fairly obvious. This program is only using one core of the 16 that I have at any given time. Look at the green lines, the G1, there's only one go routine, number 1. And even though during garbage collections, every time you see one of these lines here, we've got a garbage collection, we might be bouncing across different Ps, it's still at the end of the day single threaded. The only thing that's using more CPU is the garbage collector. In fact, if we were to, let's just say, expand this particular garbage collection here, you would see the initial stop the world. You could see here that we're doing some concurrent work phase, another stop the world over there. You might even see that we're in mark assist, which means we're also helping the garbage collector at that point. And we could see sort of what's happening there. But I think the bottom line is what this is showing us, at least right now, is that if we really want to run faster, then we should really try to turn this program into a concurrent program. Now, when I say concurrency, what do I mean? The best definition I've ever heard for concurrency is out of order execution. I love that idea, out of order execution. Given a set of things.
Right. Let me write it down, because the concurrency is a very kind of concept, because it's a very important one, as well as also it's already being confused along with the parallelism. So that's why you might have gone through a lot of different books as well, or either through blogs or either through the blogs or a lot of different things. But the real definition of any particular concept is being the real definition is being given by the experience of different developers. It isn't about the person who built it. It might be the one who can give an amazing definition, but still, people who usually get along with the different conditions in which they've been using that particular tool in the whole development industry or the domain, the definition has been given by the engineers who's been using it for a while. Obviously, the particular person who defined it or designed it, there is know about it a lot, but still, it is kind of it's they might have been so. I'm saying that you can't just rely upon the ChatGPT's definition or any bookish kind of a definition. You will have to get along with the latest definition. Definitions usually get updated as well. You can't just say a particular definition that has been given to you by 10 years ago. You can't just go along into the market and just give the same definition about the GPUs and all, because it has been used in a lot of different frameworks, in a lot of different manners right now at the moment. Earlier it was all just because all for the the display rendering and a lot of different parts, but right now it is being used for within the different domains, like for handling huge bulk of traffic within the whole servers, or either for your whole system as well, for handling the the gaming graphics that you've been using at the moment, and then later as well for the in the cryptocurrency market as well, for the blockchain mining and a lot of different things as well. At that time as well, GPUs actually came into the existence and being used. Have been they are constantly being in the demand in the whole market. That's why the RAM, the prices have been increased to a huge. These are going to skyrocket in the past weeks. because the all those programs have been going on to the AI data centers, because it's now right now for the moment they've been using it for the AI workloads and for handing up the the agents and the generative AIs and agents and all. The MCP usage, people have been using lesser MCP agents, and then they've been used a lot more MCP integrations. You might have seen a lot more MCP integrations, like a lot of different tools and frameworks in the whole industry, rather than someone using it to that scale. Right. So, yeah, what he said just now. Let me write it down. That's kind of all right, but still, like, we'll try to cover at least the definition of concurrency. What do we mean by the concurrency? It yeah, William Kennedy. William Kennedy, I guess um, he wrote one of the book, I guess. I don't know. Nah, there might be someone else, I guess. Let's hear what I was saying. What? Yeah, out of order. Execution. Perfect. Bold it and also increase the whole size of it as well. Yeah, out of execution.
Given a set of things you have to do, no matter what the order is, as long as you get them all done, everything's going to be fine. In fact, we have that.
Right.
I love that idea. Out of order execution. Given a set of things you have to do, no matter what the order is, as long as you get them all done, everything's going to be fine. In fact, we have in here, I've got 4,000 files that I need to process. In all reality, it doesn't matter what order I process them in. As long as I get all of them done, we're going to get that same result. This is a perfect opportunity for concurrency. Now, I did tell you I want to be able to process millions of files, but let's slow down a little bit. Let's just focus on 4,000. And what will be the easiest way to turn this program into a concurrent program? Well, as a first step, what would be interesting is just throwing 4,000 Go routines at it. Let's just do that. Let's get there. We know we really can't settle there, so I'm not going to throw a million Go routines. I will run out of file handles at some level before that. But it's a good first sort of step. So how do we take this program and get it so now it's going to be concurrent? Well, we've already decided that what we're going to do is identify that we're going to want to use that number of Go routines. So whatever the size of that slice of documents is, that's what we'll do. Now we've got an orchestration problem. We don't want this function to return until everything's been done. And so what we'll do then is use a wait group. And the wait group will allow us to do this orchestration, where this main Go routine will wait on the other 4,000. So we'll do our add call. We know how many we want there, G. But I can come all the way down here by the return and say, okay, we're going to wait for all that to finish. And now we've already doing the linear traversal. That's fine. We have a document. What we kind of want to do here.
But it's an amazing, kind of a tech talk that has been given by the Wayne Kennedy. But still, if anyone doesn't know as much about the whole concurrency part and the wait groups as well, or the sync packages and all those particular concepts, then it might be a little bit kind of difficult to understand for any particular person who's been watching it for the first time. Kind of sound a lot nerdy kind of a thing, but still, I'd say let's wait for the other live stream as well, because it will be a lot better and understandable as well for any particular person who will be watching this video, because you guys doesn't know as much about the whole weight groups and a lot of other things as well for now. So it's, I would say it's been already 1.5 hours. Let's just kind of back it up, and maybe in the next live we'll kind of try to cover the concurrency parts as well. For now, I guess on the new year, that is on the 1st of January, we're gonna try to cover the the Rust basic concepts as well. So yeah, thanks a lot, and Radhe Radhe, thanks a lot for all the people who viewed the whole stream. Radhe Radhe, jai Siya Ram.